this next set of slides with the last slide that I ended off with, because these Hadley cells, which are generated here, the ferrule and the polar cells, are important to just keep in your head. So I wanted to just leave you or start you where I just left you, so we have some familiarity. So what we end up getting is a series of repeating and alternating high and low pressure cells. And so here at the equator, where the initial lifting, where all that great intense sunlight's coming in and starting off our planet's motion for the atmosphere in this little zone around the equator, we get lifting happening here. So this is a low pressure cell. These purple lines are our winds. So the wind is going to come up. We're going to come across this Hadley cell. We're going to fall. So we're going to have a high pressure belt. So this whole belt is a high pressure cell. We're going to have lifting at around 60. So this is a subpolar low pressure cell. And then it's not labeled here, but I've got a high pressure cell here. And then down here in the southern hemisphere, I have a high pressure cell also. So at our first low pressure cell, which comes in and around 0 degrees latitude, is the equatorial low, also known as the equatorial trough. All right. And that trough occurs in the middle of something called the intertropical convergence zone, the ITCZ. For those of you who are from the Commonwealth, ITCZ. All right, I sometimes still call it Z. So ITCZ is the intertropical convergence zone. We're calling it a zone because when the sun is at the equator, that's where the low pressure cell is. When we move from March and we move northward, that low pressure cell is going to move with the sun. So the low pressure cell is going to be up here, and then we go from April to May, and then the low pressure cell is going to move here, and then June the sun's going to move to 23.5 degrees north latitude. So it turns out to be a zone between 23.5 degrees north latitude and 23.5 degrees south latitude. That means that the winds that are purple are going to move along with it. Now it's convergence zone because this wind is converging onto the low here, and these winds are converging onto the low here. So it's the intertropical convergence zone. The other low pressure zones that are at 60 degrees latitude north and south are called the subpolar lows. And sub is because they're below the poles. Remember, poles are at 90 degrees, so 60 is below 90, so this is a subpolar low, and I've got a subpolar low here also. Our pressure zones are our 30 degrees latitude, and if the sun is going to push northward in the northern hemisphere in March, April, May, June, then it's going to bump up against the high, and it's going to cause the high to move. Not as much as the low moves, but it's going to force the high to move a little bit. It's like standing in line and somebody gives you a push, right? You might not move as much as the person pushing you is moving, but you're definitely going to react to that move and to that energy of push. So our highs are going to move a little bit northward during those months, and those are subtropical highs. All right, and then we've got our polar highs here. That subtropical low, because the high is moving, the subtropical low is going to move as well. So it happens in sequence, like a domino effect. So this is what we've got in the northern hemisphere. The southern hemisphere is exactly the same. I go from the intertropical convergence zone to a subtropical high to a subpolar low to a polar high. So we're alternating high, low, in the northern and southern hemispheres each. All right, I think this is a handy little nice and neat diagram to give you some more contextual, maybe easier to read recognition of where those winds are, which are in purple, where the highs and the low cells are as well. It gives us a cold front up here too, but we're not going to worry about that cold front for another unit yet. Okay, for now I've got 2 more slides and then I will call this little bit done with. So this diagram's coming out of your textbook, and I think it's a really nice and neat diagram to recognize how these Hadley cells function. So nice warm energy here. Remember, we're lifting. As we lift, then because the particles are far apart, they're cooler, so they're going to start to fall. So they fall as they're moving northward, and they fall as they're moving southwards, right? This is a large cloud mass that's generated, and note that the cloud mass is generated all the way through. And the other reason I really like this diagram is it shows you that this is a belt of energy. These are just happening in localized areas on the sides of the planet. This comes all the way across, just like a big tube, if you will. We have a similar tube that happens here with the ferrule cell, and a similar tube that happens up here with the polar cell. All right, but it's just too much to draw. Nice winds that are drawn here as well. So at this junction, I want to make sure that we understand what winds are. And remember, I told you really pay attention to the direction that these winds, our arrows are going. So in this case, all of the winds that are coming out of the 30 degrees north latitude are pushing across towards the ITCZ, the Intertropical Convergence Zone, and they're moving from the east towards the west. All right, and winds are named from where they come from and not where they're going. So in this case, it's from the north to the south, and it's moving westward. So these are the northeast winds, or sometimes just called easterly, more commonly known as trade winds. All right, I'm going to come back to that term here in a moment. Likewise, in the southern hemisphere at the same latitudes between 30 and 0 degrees, the winds are coming from the high to the low. They're rotating in the opposite direction, but they're moving in the same direction. So they're moving from the east to the west. So these are easterlies again, but they're coming from the south. So they're southeasterlies, and they're trade winds. So if we look at where this high pressure cell is situated, it's situated at 30. Earlier in the year, when the high is sitting up here, we're off the coast of Spain or France and Great Britain. We can pick up the energy coming out of this high pressure cell. And if you were involved with trade, you would come across with a pretty relatively empty ship, just the materials that you need to get across the Atlantic Ocean. You pick up one of these trade winds, and the trade winds handily send you right to the land of gold and coffee and chocolate, and you fill up your bounty here, and then you come around, and as this cell moves, it's going to rotate around, and you're going to use some localized winds through the Caribbean, pick up here, and now we've got winds moving from the west to the east. So they're named from where they come from, not where they're going. So these are our westerlies. So the westerly winds handily are taking you back home to Britain and France and Spain and Portugal, across the westerlies with everything that you have acquired. Let's be gentle with some of this language. Acquired, and you're moving across the North Atlantic. Same thing happens in the southern hemisphere. You're going to come off of Africa, and you're going to, with the trade winds, move across into South America, where you're going to be doing some business, and then rotate back around using the westerly winds to get you back to Africa. So this period of commerce at this time benefited from the physical geography related to atmospheric circulation. All right. The last little bit of winds that I want to share with you then are the polar easterlies. They're coming out of the out of the east and then moving westward. You can't see it on this diagram here, but there are polar easterlies for the southern hemisphere at Antarctica as well. Okay, if the diagrams that I gave you for all of the atmospheric circulation at the global scale wasn't so groovy for you, I've got my absolute favorite, which is this one, and I just included to give you another diagram to consider. All right, so this is what we've got. The nice thing about this is it clearly gives you the Tropic of Cancer, which is 23.5 degrees north, and the Tropic of Capricorn, which is 23.5 degrees south.